Welcome back, guys, to our DSA challenge series. In this particular phase of the series, we are looking at the questions which are based on graph data structure. So let us see our today's question. Our today's question says snakes and ladders. The question is pretty lengthy, so I'll explain you it in the short. I hope you all would have played the game of snakes and ladders in your childhood, in which we are given a board in this manner and we start from 1 and we need to reach 36 at the earliest. The one who reaches 36 at the earliest wins the game. And we are given with a dice which contains the numbers labeled from 1 to 6. We need to roll a dice and whichever number comes, that much steps we move forward. And in this particular board, the ladders are there and the snakes are there. From the ladders, we rises up. For example, in this from 2, we are rising up to 50. And from snake, we come down. That is from 17 to 30. So the question is very much similar to this game of snakes and ladders. So let me explain you the question. We are given a board of snakes and ladders, which is in which the numbers are labeled, written in the bootstrap-it-on style. That is 1, 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11, 12. Then from first of all from LHS to RHS, then RHS to LHS, then LHS to RHS, and so on. So we are given with the board. Now how the board is labeled? We are given an array board. If the array contains -1, that means that at that particular number, neither a snake is there nor a ladder is there. For example, this 1. Here it is labeled as -1. Now, as from 2, there is a ladder and we reaches till 15. So that is why 15 is labeled over. So in our array of board, at every location, we are given a position at which we can reach from that particular position. That is from 2, we can reach to 15. So 15 is labeled. So if something is written, that means we can reach from 2 to 50. And in the same fashion, if -1 is there, that means it neither contains a ladder nor a snake. Now what we need to do? We need to return the minimum number of steps which are required to reach from 1 to 36. Now the moves. What about the moves? In moves, we can choose any number as per our choice based on this criteria. That is current plus 1, comma, min of current plus 6, comma, n square. That is, it's our wish. If we want, if we are at 1, we can go to 2, 3, 4, 5, 6, or 7. It's our choice. So we need to return the minimum number of steps in which we can reach from 1 till 36. So I hope the question is very much clear to you all now. Now we are talking about the minimum number of steps. So whenever the word minimum comes, what strikes to our mind is Dijkstra's algorithm, right? So we are going to apply Dijkstra's algorithm in this question, and the question will become pretty simple. So now let us understand this particular question with the help of the code given to us. See, what we were given in this question, we were given the board set. So in Dijkstra's algorithm, first of all, we make a queue. So here we have defined a queue data structure. We have pushed our starting index. What we are starting from 1. That is why we have pushed q dot push 1. We have defined calculate the size of this board. Int n equals to board dot size, and goal is n into n because we need to reach till n square, right? We are starting from 1. Our goal is to reach till n square. That is why we have assigned goal with n into n. After that, we have defined a distance array, and initially we have declared each index of that distance array to int max, that is 1e9, 10 raised to the power 9. And we are starting from index 1, so that is why distance at the index of 1 will be given a value 0. Because we are requiring 0 steps to reach till 1, so that is why distance at the index of 1 is 0. Then we have applied Dijkstra's algorithm, that is while not equal to q dot empty int current equals to q dot front, then q dot pop. If current double equals to goal, it means we have reached till that particular index, that is n square, that we want. So we will directly break up this loop. Otherwise, what we can do? We can move 1 step forward, 2 step forward, 3 step forward, 4 step forward, 5 step forward, or 6 step forwards. Total 6 choices we have. So that is why that we have applied a for loop for int I equals to 1, I less than equal to 6, I plus plus. Int next equals to I plus CUR. That is our current index. Suppose we are at 2. So 2 plus 1 is 3. We can reach to 3, 4, 5, 6, 7, 8. So that is why next is giving us that value. Int next equals to I plus current. Then we are checking if next is greater than board. Suppose we are at 30. Our board is of 6 cross 6. That is our last number is 36. And we are at 35. Now 35 plus 2 is 37. This loop will iterate in 6 steps now. So one time we can go reach till 36. In next move we can reach till 37. So 37 is not in the goal. So we will check. If next is greater than goal, then we will directly continue. It means we will not execute this further lines because it is out of the board index. Board is labeled only till 36 number. So that is why we will continue that. Otherwise, if the number is within the board index, we will calculate its board, whether the array which is given to us as board. So we will find the row column that is next minus 1 divided by n and column that is next minus 1 mod. This will help us to find if suppose we are at 1. We are reaching till we want what is present at index, what is present at 2. So what we will do, we will find 2 in our board array. So for that we have find the row and the column since it is a 2D vector. Then we will find board at the index of n minus 1 minus r and r. We are applying a ternary operator. If r mod 2 double equals to 0, then we will go to c. Otherwise, we will go to n minus 1 minus c. This is helping us to find what is present at 2. Let me explain you. This was the board vector which was provided to us. Now we are at 1. We want to find what is present at 2. So for that, we need to find this row column and the row index and the column index. So if we have finded the row index and the column index, then we are storing at vertex this value 15, which is helping us to know what is presented. I hope you are getting my point. So this row index we have calculated int r equals to next minus 1 slash n and column that is next minus 1 mod. Now what is present is we are storing it in vertex board at the index of n minus 1 minus r, and if row mod 2 double equals to 0, then we will find c. Otherwise, we will find n minus 1 minus c. That is the ternary operator we are. Now in vertex, we have stored whatever is present over there. Then we are checking if vertex is not equal to 0. Then next is equals to if vertex is greater than 0. Our vertex can contain only two things, either minus 1 or anything towards which we will reach from that particular number. Suppose 2 is containing 50, because from 2 we can rise up a ladder and reach till 50. So if it is greater than 0, so what we will do? We will store that particular value in our vertex. Otherwise, we will keep storing next value. Then we will check if distance at the index of next is greater than distance at the index of current plus 1. I hope if you have, if you know Dijkstra's algorithm, we always check if the distance that we are taking to reach till this particular index is greater than distance at the index of current plus 1, then we will update the value. Otherwise, we will not update the value. We will keep the value same. That is distance at the index of next equals to distance at the index of next. We will push this next in our queue and we will update the value of vertex to 0. So once this loop get completed, if we are able to reach that particular index, then this will break. And if this will break, then we will return whatever is present at our distance at the index of code. Otherwise, if this loop get completed, then what will be present at distance at the index of code? That is int max. That is 10 raised to the power 9, which we have initially given to it. So if that value is present, it means we cannot reach till n square. That is our goal. So we will update the value. We will return minus. So I hope the question is clear to you all. If the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.